Hey everybody! In this video we're going to be doing some questions regarding AC generators. The first question, what current would flow if an AC generator was built with a split ring rather than a slip ring? We know from our AC videos was that the AC and DC are very similar. In fact, the only major difference is they have a different connection to the rest of the circuit. A DC generator had one ring that was solid apart from the fact that it had two breaks in it. So it was split down the middle. The other type of ring that we had was a solid ring, but we had two of them. Both of these rings had brushes connected to them, but they behaved differently. This type of ring allowed the current to flow in the same direction throughout the entire time. This is what we originally had when we discussed a DC motor. This was the type of ring setup that we discussed when we had an AC generator. So if we had a split ring, which is this one over here, compared to that of a slip ring, which are these over here, we would end up with a DC flow rather than an AC flow. Our next question, a square coil has lengths of 0.10 meters, is made up of 400 turns, and is rotated at 10 Hz in a magnetic field of 0.1 Tesla. Calculate the maximum and the average, the root mean squared, induced EMF. Well, we want to calculate our maximum, so our formula for that is that our maximum EMF is equal to 2 pi, the frequency, times by the number of coils, times by the magnetic field, times by the area. To which we can actually just plug in some numbers. So we get that 2 pi, the frequency, the 10 Hz, times by the number of coils, 400, times by the magnetic field, which is 0.1, times by the area, which is, for a square, the sides times each other. So it's going to be 0.1 squared, which comes out to be equal to 25.1327, etc., 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 or to two significant figures, 25 volts. Now we need to determine what the average, root mean squared, of the induced EMF is. Well, we know that our EMF root mean squared is equal to our maximum EMF divided by the square root of 2. Which we know that our maximum EMF is approximately equal to 25. So substituting that in and putting this into the calculator gives us 17.6776, etc. So this comes to two significant figures as 18 volts. So from this we have determined what the average, the root mean squared, and the maximum EMF produced by this generator is going to be. In summary, this video has briefly talked about the differences between AC and DC generators, as well as calculated the maximum and root mean squared of a generator. Thanks for watching. See you in the next video.